In this video, we're going to discuss the solutions for the sample midterm on statistics. The exam contains 3 parts. The first part contains 10 short answered questions, where the students are required to write down the answers inside the boxes. In the second part, there are 10 multiple choice questions, where the students are required to choose the right answer. And there are 4 problems in the part number 3. So let's start with the first part. The first question is, we're given the 2 classes for the frequency table and we're required to find the width of those classes. So we can find the width of the classes by subtracting the 2 lower class limits or 2 upper class limits. So in both of the cases, the width is equal to the 10. The width of the classes is equal to the 10, not just the subtraction of the lower class from the upper class. So which graph is best for the paired data? So if you are given the data in the form of x and y, which are paired, then you can draw them by just putting the x-axis and y-axis and points, where the point is going to be the intersection of the x coordinate and the y coordinate of the data. Then this graph is called the scatter plot. So the scatter plot are really useful when we would like to understand whether there is a correlation between the x and y, whether there is a dependency between x and y. The range, standard deviation, and the variance are all measurements of variation. So if you are given the steam plot in this form, the numbers are going to be 52, 52, and 59. Question number 5 is we need to find the mean, median, and the mode of the 6 numbers. So in order to find the mean, we just need to add all the numbers. And divide them to the 6. So if you add them, it is going to be 4, 7, 11, 16, 24 divided to the 6, it's going to be 4. So the mean is 4. So the median is the number which is going to be in the middle. So I need to take the average between these 2 numbers. It's going to be 3.5. And the mode is the most frequent number, which is going to be here 2, because the frequency of this 2 is equal to the 2, right? So the 2 appeared in our sample twice, while all the other numbers appeared only once. So if the data set has the mean 10, standard deviation 3, and what is going to be the z-score for this corresponding time x is equal to the 5. So we need to use the formula x minus mu divided to the sigma. Here it's going to be 5 minus 10 divided to the 3. It's going to be minus 5 over 3. So if the probability of some event A is equal to the 0.4, what is the value of the probability of its complement? So we know that the probability of the A plus probability of its complement is equal to the 1. So if we substitute to the probability of A 0.4, so which number I need to choose for this so that it is becoming equal to the 1? It should be 0.6, so that the sum is equal to the 1. So a box contains 3 blue, 5 red, and 4 white chips. What is the probability of picking the blue chips? So we can find the probability by counting the number of the blue chips in the box, which is 3, and we have to divide this to the total number of the chips which are inside this box. It's going to be 3 plus 5 plus 4. It's going to be 3 over 12 or 1 over 4. If 1 and 2 are the only possible values of the random variable, and if their probabilities are 0.7 and 0.3 correspondingly, what is the expected value? So we just need to create the probability distribution table where x can take the values 1 and 2, and the probabilities are going to be 0.7 and 0.3. So the expected value of the x is obtained when we multiply the 1 to its probability and 2 its probability, and we have to add them. It's going to be 1.3. in how many ways one can arrange 5 books in a row. So let's say I've got 5 different books, and I have 5 places to put them. So first, second, third, fourth, and fifth places. So I need to figure out in how many different orders I can put these 5 different books. So let's start counting the number of the ways I can create for the first place. So I can choose any of these books to the first place, right? There are 5 different options. So once you choose one of them, for example, let's choose the A for the first, then you can have 4 different options for the second. So once you choose one of them, for example, C, then you're going to have 3 different options to here, then 2 options to here, then 1 options here. So according to the fundamental counting rule, the number of the options is going to be, when we just multiply the number of the options for each of the boxes, it's going to be 5 factorials. So these are all the questions for the first part. Let's talk about the questions on the second part. The first question starts with the combinatorial analysis question. So there are 3, so in the license plate, there are 3 letters followed by the 2 digits, right? 2 digits and 3 letters. So we need to count how many different license plates we can create if the repeats are not allowed. So we cannot use the same number or the same letter twice. So for the letters, so there are 26 English letters, so we can use all of them or any of them for the first place. So once you use one of them, in the second place you can use only 25 of them. And once you use any 2 of them for the first 2, you can use 24 of them for the third place. The same with the digits. So for the first place, you can choose any digit from 0 to the 9. And for the second place, you need to choose 9 because you've chosen already one before. So the number of the options for the number of the ways you can create the license plate is going to be 25, 24, multiplied to the 26, multiplied to the 10, multiplied to the 9. So this is going to be this option, since you can write down the 26, 25, 24 as the 26 factorials divided to the 23 factorials, right? So if you divide these factorials, you can get exactly this value. Multiplied to the 10, multiplied to the 9 is option D. So the second question, the salesperson makes the cold calls trying to sell some product, and probability that the call is successful for single trial is 1/50. So whether or not he's successful is independent from one call to the next. If he calls 50 people, the number of the successful calls is the binomial distribution. Question number 3. So if the A and B are independent, which of the statements are true? Right? In general. So this option is true always when A and B are independent, while all the others might be true, might be not true, even though A and B are independent. What is the stratified sample? So we need to choose, I think, this option C. We subdivide the population into the subgroups, then we draw a sample from each of the subgroup. It's called the stratified sampling. So given the following table, so we need to answer whether this is the probability distribution table. So in order to know this, we need to add all these 4 probabilities. So we know that all the probabilities should be between 0 and 1, and the second condition is the sum should be equal to the 1. So let's sum all of this. It's going to be 0.125 multiplied to the 2 plus 0.375 multiplied to the 2. So if you take out the 2 from the brackets, what is left is 0.125 plus 0.375 it's going to be 0.5. If we multiply this to the 2, we will get exactly 1. So yes, this is the probability distribution table, and we can find the expected value or the mean for the random variable by just multiplying the x to its probability. Then we have to sum this, right? And the standard deviation is obtained when we subtract the mean from each of the values of the x, we square them, right? And then we have to multiply this to the probability of this corresponding x, and we have to sum this. So then the square root, it's going to give me the standard deviation. So this is going to be the option number C. So a student earned grades, the following grades for the homeworks, for the 5 regular tests. Then she earned the grades 90%, 90 from the final, 92 on her class projects, and combined homework grade is 77. So we need to count her final grade. So we know the weights of the grades for each of these sections, right? So she can get, so her 5 regular tests, they are going to be 60% of her final grade. It's going to be basically 0.6, right? So final exam counts only 10%, so the final exam is only 10% or 0.1 from her final grade. The class projects count 15% projects. It's going to be 15% or 0.15, and the homework counts 15% or 0.15. So please note that if I sum all of this 4 numbers, I need to get 1, right? 100%. So what I have to do is I need to find her final grade. So her final grade is going to be, so the regular test multiplied to the 0.6 plus final grade, final exam grade multiplied to the 0.1 plus projects, it's multiplied to the 0.15 plus homeworks multiplied to the 0.15, and we have to calculate this. So please note that you can take out the 1 divided to the 10 or 100 from the brackets, 1 divided to the 100. So if you multiply everything to the 100, it will be RT multiplied to the 60 plus F multiplied to the 10 plus P multiplied to the 15 plus H multiplied to the 15, right? So if you divide everything to the 100, you will obtain this table. So this is the weighted, this is how we need to find the weighted average. So the regular test, so in order to find, so it is already given that her final grade, so her result for the final exam is 90. And the result for her class project is 92, right? It's already given, and the homework is already given. It is 77. So the only thing which is not given is the projects. Her regular test. So in order to find the result for the regular test, just as a 1 number, so I need to find the average of this 5 numbers. So basically, I need to add 78 plus 71 plus 83 plus 92 and divide it to the 5. This is going to be the result for the regular test. Then I have to scale this with the 60, right? So the option which corresponds to this solution is going to be C option. A pair of dice rolled 36 times. So basically, we've got the dice, so the 2 cubes. And we have to roll these 2 cubes 36 times. And what is the probability of getting at least 1 time the pair of 1s? So basically, once I've got the 1 and 1, right? At least once. And we have to, so we need to find the probability. So find the probability that the number of the, this kind of pair is going to appear at least 1. It means more or equal to the 1. So this is going to be equal to the 1 minus probability that this kind of pair never appears, right? Is 1. So if you roll a die once, what is the probability that you will not get this pair, right? So probability that you will get this pair, 1 and 1, when you roll dice once, it's going to be 1 over 36, right? 1 over 6 is probability of getting 1 for the first. Multiply it as a 1 over 6, probability of getting 1 for the second. And probability of not getting 1 and 1 is going to be 35 divided to the 36, right? All other options. And probability that you will not get 1 and 1 for the 36 trials is going to be 35 divided to the 36 in the power of 36, right? So that is why the probability of getting at least once this pair of 1 and 1 is going to be 1 minus 35 divided to the 36 in the power of 36. Problem number 8. So there is a standard deck of cards. We're going to choose 3 cards without replacement. It means that we will not put the card back to the deck. So what is the probability that the first card is the king or club? So we need to use the additional rule. So the king or club, it's going to be a probability of choosing the king for the first trial plus probability of choosing any card which is club minus probability of the king and club. It's going to be, what is the probability of choosing any king? There are 4 kings, 52 cards. It's going to be 4 over 52 plus, what is the probability of choosing any card which is clubs? It's going to be 13 different cards or clubs. So there are 52 cards. Probability of choosing any card which is going to be clubs is 13 over 52 minus, what is the probability of choosing card which is king and club? So there is only one card which is going to be king and club, so it is going to be 1 divided to the 52. So the option which corresponds to this, it's going to be the second option. So what is the probability that the third card is a 7, given that the first 2 are queens? So if the first 2 cards are queens, so we choose the first card, which is queen, right? And we don't put this back to the deck. So we choose again second card, which is another queen, and we don't put this back to the deck. So how many cards we've got in the deck? So how many cards left in the deck? So there are 50 cards left in the deck because we choose the 2 and we didn't put them back, right? And how many 7s we have in the deck? We have 4 7s in the deck, right? Because we know that we've chosen the queens in the first 2 trials, and probability of choosing the 7 on the third trial is going to be 4 divided to the 50, so which is this option. So what is the probability that all 3 cards are face cards, basically the ace, king, queen, and jack, right? So how many aces we have in the deck? So there are 4 aces, right? Plus 4 kings, plus 4 queens, plus 4 jacks. So there are 16 face cards in the deck. So probability of choosing any of them for the first trial is going to be 16 over 52. We have to multiply this. So if you choose one of them, how many will left? So 15 over 51. So if you choose one more time, it's going to be 14 over 50. So unfortunately, there is no such answer. But the correct answer should be like this. So in the problem number 9, so there are just given numbers. We need to find the range, variance, and standard deviation, and we need to use the calculators to do this. So if you remember, so in order to calculate the range, we need to find the minimum value and the maximum value, and we have to subtract them. It is going to be equal to the range. So in order to find the standard deviation, we need to find the mean. First of all, by summing all the numbers and dividing them to the 10, we can find the mean. And we can find the standard deviation by subtracting the mean from each of the numbers, squaring them, and taking the average. Basically, we have to sum this and divide this to the 10 again. Or we can just use the scientific calculator to calculate the standard deviation and the variance. And please note that the variance here is going to be just simply the square of the standard deviation. So the correct answer for this problem is going to be the A option. So in the problem number 10, we're given a sample. We need to find the median, and the two quartiles in the left hand side and in the right hand side of the data sample. So what we need to do is we first of all need to sort all of these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we need to find out the mean. So in order to find the mean, I need to find the average of this two, so which is going to be 13, so which is going to be Q2 in our case. So the Q1 is going to be the median of the first half, so of the 6 numbers, it's going to be the mean of these two numbers, so 6 and 7, right? Which is 6 and 8, sorry. So the mean of the 6 and 8 is 7, so which is going to be the Q1. And in order to find the Q3, we need to find the median of this, the right hand side part of the data sample, which is going to be the mean of these two numbers, which is going to be 16.5, which is Q3. So the option which corresponds to this is going to be DA. Now let's talk about the problems in the third part. So in the third part, we are given the problems and we need to first of all find the mean. So this is the frequency table, and it basically tells us, hey, there are 7 appearances of the 10. So basically it is going to be 10, 10, 10, 10, 7 times. 15 is appeared 10 times. 20 is appeared 5 times, 25 is 2 times, 30 is once. So in order to find the mean, as you remember, we need to sum all the numbers, right? So there are 7 tens, we have to sum them, which is going to be 70, right? Or you can write this 7, multiply it as a 10. There are 10 15s, we can sum 10 15s, or we can just multiply 15 to the 10, plus 20 multiplied as a 5, plus 25 multiplied as a 2, plus 30 multiplied as a 1, and we have to divide all of this to the number of the numbers in our sample, right? Which is going to be 7, plus 10, plus 5, plus 2, plus 1. So which is going to be 400 divided to the 25, which is 16. So the mean of the sample, which is going to be 16. So in order to find the standard deviation, I need to create again the different table where I need to write down x minus mu in the square, right? And the frequencies are going to be the same. So if I subtract the 16 from the 10, which is going to be minus 6, if I square this, it's going to be 36. So 15 minus 16 is minus 1, and the square is 1. 20 minus 16 is 4, and the square is 16. 25 minus 16 is 9, and its square is 81. And 30 minus 16 is 14, and the square is 196. And I need to copy the same frequencies. It's going to be 7, 10, 5, 2, and 1. And in order to find a variance, I need to sum all of these numbers multiplied to their frequency. So basically 36 multiplied to the 7, plus 1 multiplied to the 10, plus 16 multiplied to the 5, plus 81 multiplied to the 2, plus 196 multiplied to the 1. And we have to divide this to the number of the numbers again, which is 25. So if you calculate this, we can get for the variance the value 28, and the standard deviation is going to be the square root of variance, which is square root of 28, which is 5.27. 5.27. So in the last question, we said that suppose that we don't, if you couldn't find a mean on the first problem, in the first part, let's just suppose that this is some constant m, multiply each number here for the a, right, and subtract the b from each of the number and find what is the mean in terms of this constant m. So either you can multiply each of the numbers as a and subtract the b, either we can use the formula for the expected value. So let's say we found the expected value of the x is equal to the m, right, or the mean of the x is equal to the m. So we are going to create the new variable, which is obtained by multiplying each of the values of the x as a and we have to subtract the b from this. And we're asked to find what is the expected value of the y, which is going to be the expected value of the x multiplied to the a minus the b. And we can apply the expected value for each of these terms. It's going to be expected value of the constant multiplied to the x minus the expected value of some constant. So basically, if we multiply our data to some constant, it is going to be the same as this constant multiplied to the mean of this data set. And if all of the data sets are just the constants, for example, 1, 1, 1, 1, 1, the mean of this 5 numbers is also going to be just the constant, right? For example, if you have 1, 1, 1, 1, 1, the average of this, it's going to be, when we just sum all of this and divide this to the 5, it's going to be again the 1, the same constant, right? So that is why the average of the constant is the constant. So we know that this is m, so it's going to be a multiplied to the m minus b. So this is the average of the new variable in terms of the m. In the second problem, we are given just the sample data. We need to find the frequency table, and we need to find the average of this frequency table. So first of all, it is better to sort the data. It will be easier for us to count the frequencies. So I need to start from here. So the 2 is here. So the 4, 42, 53, 55, 59, 64, 65, 66, 68, 69, 70, 74, 75, 77, 78, 79, 86, 86, 86, 88, 89, 90, 91, 95. So if I count all of the frequencies, I will get the numbers. 2, let me write it here, 2, 1, 3, 5, 6, 5, and 8. So this is going to be the frequencies. In order to find the relative frequencies, I need to sum all of the frequencies, which is going to be 25, and I have to divide each frequency to the total amount of the frequencies, which is going to be here 2 divided to the 25, 1 divided to the 25, 3 divided to the 25, 6 divided to the 25, 5 over 25, 8 over 25. It's going to be the relative frequency table. So if we would like to find the mean, so we need to find the middle of the range, class range. It's going to be 30 plus 40 divided to the 2, which is going to be 35, right? So we multiply the 35, the middle of the class, to its frequency or to its relative frequency. So 2 over 25 plus 46 multiplied as 1 over 25 plus 57 multiplied as 3 over 25 plus 68 multiplied as 6 over 25 plus 79 multiplied as 5 over 25 plus 90 multiplied as 8 over 25. So if we multiply all of these numbers, all of these terms, and add them, we are going to get 72.4. So we can approximately find the mean of this 25 numbers without having them, right? So if we just have the frequency table. And in the last part, we need to draw the histogram of this frequency table. So in order to do this, first of all, we need to put the middle of the class ranges, or we can just put the 30 to the 40, so to the 50, 60, 70, 80, or it was different, right? So we need to put the 30 to the 40, 41 to the 51, 52 to the 60, to 63 to the 73, 74 to the 84, 85 to the 95. Then we need to put the bars according to the heights. So it's going to be roughly, was it 2, 1, the third one was in the third class 3, then it was 6 here, then 5, then 8. So this is going to be the histogram of this frequency table. In the part number 3, we're given a problem which is slightly difficult to solve. So we need to roll roll 2 pieces of dice, and we need to find the expected value of the sum. So in order to do this, first of all, we need to find, so previously, we find the expected value of some variable by just multiplying the values, all possible outputs, to their corresponding probabilities, and we sum this, right? So we first of all need to find what is the probability distribution table for the x or for the y. So let's say x in our case is going to be this sum, right? So in order to do this, so in order to solve this problem, first of all, I would like to introduce the new variable. So z, let's say it's going to be the number on the first die, right? And the x is going to be the sum of the 2 dice. So here in our table, x, here is going to be x. So first of all, so if the first number is 1, what is the probability that the sum is equal to the 2? So if the z is equal to the 1, what is the probability that x is equal to the 2? It's basically, I need to obtain 1 on the first die and 1 on the second die, right? And the probability is going to be 1 over 6 multiplied to 1 over 6 is 1 over 36. If the number on the first die is 2, what is the probability that the sum is 2? Is simply 0, because the second die is going to be at minimum 1, right? So if the first one is 2, the minimum sum is going to be equal to the 3, right? So the same is here. So if the first number on the number on the first die is 3, then the sum is equal to the 2 is 0, 0, 0, 0. So if the number on the first die is 1, this probability that the sum is equal to the 3 is, again, 1 over 36, because the first one is going to be 1, the second one is going to be 2, right? So if the first one is 2, then the sum is equal to the 3 is 1 over 36 again. If the first one is 3, the sum is equal to the 3 is 0, 0, 0, 0. If we fill the table in this manner, we're going to get this table. So if the first one is 1, probability that the sum is 7 is 1 over 36, 1 over 36. Now, if the first one is 1, probability that the sum is 8 is again 0, because the second die cannot be 7, right? So then it's going to be 1 over 36. Then we've got 2 zeros here. Three zeros. So the distribution table is going to be like this. So now, so the sum or variable x here is going to be the sum of the 2 dice. It's going to take the values 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is the probability that x is equal to the 2? It's going to be the sum of all of these possibilities. It's going to be 1 over 36. Probability that the sum is equal to the 3 is 2 over 36. This is 3 over 36. Basically, I need to sum all of the 3 numbers, right? Probability that x is equal to 5 is the sum of these 4 numbers. It's going to be 4 over 36. 5 over 36, 6 over 36, 5 over 36, 4, 3, 2, and 1. So in order to find the expected value of the x, what I have to do is I need to multiply the output to its probability, right? So basically 2 multiplied to the 1 over 36, or I can take out the 36 from the brackets because all the numbers have the 36. It's going to be 1 multiplied to the 2 plus 3 multiplied to the 2 plus 3 multiplied to the 4 plus 4 multiplied to the 5 plus 5 to 6. So if we multiply all of the numbers and add them, we're going to get 252 divided to the 36. If we divide this, it is going to be 7. So now we need to create the new variable, in our case, y, which is going to be x squared minus 6x plus 1. And we need to find its expected value. So the expected value of the new variable y, it's going to be the expected value of the x squared minus 6x plus 1. We can apply this expectation for all of the 3 terms. It's going to be expectation of the x squared minus 6 multiplied is the expectation of the x plus the expectation of the constant is going to be simply constant. We just found that the expectation of the x is equal to the 7, and in order to find the expectation of the x squared, what I have to do is, so previously I just multiply the x to its probability, so 2 to its probability, 3 to its probability, 4 to its probability, and so on. What I have to do now is I need to square each of the values for the x, and I have to multiply them to its probability. So basically it's going to be 1 over 36 here. It's like square of the x multiplied to its probability, right? 4 multiplied to the 1. 4 multiplied to the 1. Plus the next term is going to be 3 in the square is 9. 9 multiplied to the 2. Plus, so 4 in the square is 16. 16 multiplied to the 3. 16 multiplied to the 3 plus, and so on. So we can do this, we have to do this for all of these terms. And in the sum, we're going to obtain 1974 divided to 36, which is going to be roughly 54.83. So now we need to calculate this. So the expected value of the y, it's going to be 54.83 minus 6 multiplied to the 7 plus 1. Which is going to be 13.83 approximately. The last problem is about the standard normal distribution. So the IQ scores have this normal distribution with the mean 100 and with the standard deviation 15. So we need to find the probability of the random variable. So if I choose one of the adults randomly, what is the probability that his IQ score x is going to be more than 115? So in order to do this, what I can do is I can find this like a probability of x is less or equal to the 1.15 or 115. And let's find the probability that if I choose one of the adults randomly, his IQ score is going to be less than 115. So what I'm going to do is I need to find the corresponding z-score for both of the parts. It's going to be probability of x minus mu divided to the sigma. So because it is going to be equal to the z, right? Since I did this for the left-hand side part of this inequality, I have to do the same thing for the right-hand side. It's going to be 115 minus mu divided to the sigma. So this is going to be probability of the z is less than 115 minus 100 divided to the sigma, which is equal to the 15, right? Which is equal to the 1 simply. What is the probability that z is less than 1? So if I draw the standard normal distribution table, so we know that for the standard normal distribution, 0 is going to be here, standard deviation is here, 1. I need to find the area until 1. So in order to do this, we just need to find a phi of 1 from the table. So this is the cumulative distribution table. So from here, I need to find the value of the probability for the z, which is equal to the 1. So when the z is equal to the 1, I need to find a 1 from the first column and 0 from the first row, so that their sum is equal to the 1. It's going to be 0.84,134. So I need to substitute it to here. So phi of 1 is going to be 0.84 roughly, right? So probability that a randomly chosen person has IQ more than 115, it's going to be 1 minus probability of the x is going to be less than 115, and we found out that the probability of x is less than 115 is equal to the 0.84, which is going to be 1 minus 0.84, which is roughly 0.16. So probability that if I choose one adult randomly, that his IQ is going to be more than 115 is 16%.